This video is about astrobiology and alternative biochemistries. Generally speaking, astrobiology is the study of what alien life could be like. It's about how alien life could emerge, evolve, and how it could be different from life on Earth. It includes a wide range of different ways in which this could happen, ranging from alien life having to deal with different environments to it being based off completely different chemistry than Earth life. Alien life will be heavily determined by the conditions of the planet and star. Larger stars, for example, will have more distant habitable zones, which is simply the zone where liquid water can exist on a planet with an atmosphere. The problem is that large stars don't generally exist for very long, and when they do finally run out of time, they violently explode, which would surely destroy any planet that orbits them. So, although it is possible that life could emerge on a planet orbiting a large star, since the star would not exist for very long, it would not be a good candidate for evolving large biospheres like, for example, what we see on Earth. Life might not become as advanced on that planet because the planet would not exist very long. Stars similar to the Sun or smaller are good candidates, however. They tend to live for a decently long amount of time, and they also tend to have lots of planets around them. The Sun is actually one of the worst candidates in this category, because yes, the Sun does live for about 5 billion years, but the amount of time with which, say, the Earth would remain habitable is actually much lower than that, because as a star ages, it actually sort of heats up, the energy intensifies. So in just a few hundred million years from now, the Sun will have gotten brighter, and bright enough to where the Earth would no longer be in the habitable zone of the Sun. So although the Sun is still a good choice for evolving alien life, it is not the best choice. There are smaller stars that would be better candidates for having Earth-like planets around them. However, you don't want to go too small, because although small red dwarfs do tend to have planets around them, there are some problems. For example, planets orbiting red dwarf stars tend to be tidally locked, which means they only show one face to the star. And although this does not completely remove the possibility of life, it does certainly limit it. Life that evolves on the planet would be more restricted, would need to deal with possibly harder conditions, because depending on how the weather, how big the atmosphere of the planet is, the one side could be too hot and the other side could be too cold for life. But even if the planet does have a large atmosphere, which it certainly could, it could have a Earth-like atmosphere that properly distributes heat. But even if it does have that, one side of the planet will remain in complete darkness forever, which means that that side will never be able to develop things like photosynthesis, which are essential for modern large complex ecosystems. I would say among the best candidates would be stars that are in between the size of the Sun and red dwarf stars. These stars live for a long time, tens of billions of years, and any planets around them would not be tidally locked, or at least have a much lower chance of being tidally locked. So this allows the planets to properly rotate and have things like day-night cycles and not have too extreme conditions. These habitable planets can range in size and composition. They can be smaller than Earth or even larger than Earth and still be habitable. They simply need to have atmospheres, and they need to have things like generally they need to have things to protect that atmosphere, like magnetic fields mainly. Carbon is the most likely element that life in the universe, or most life in the universe, will be based on. It's very common and reactive. It's the fourth most common element in the universe. So it's found basically everywhere, especially on places like rocky planets that are orbiting in the habitable zones of stars, which is coincidentally a great place for carbon-based life to exist. Carbon's ability to form four-way bonds is what allows it to be such a good ingredient for forming life, because it can form complex molecules. Carbon-based life is not the only form of life that could exist in the universe, however. There are other possible forms of biochemistry, although most of them do seem to be pretty limited in comparison. Silicon-based life could exist. This life would be unlike, based on the silicon atom instead of carbon. The problem here is that silicon bonds are not as stable and complex as carbon bonds. They might not exist as long, and silicon-based life likely wouldn't grow to the extreme complexity of carbon-based life. So it would most likely be restricted to microbes, bacteria. However, it is possible that silicon-based life could survive more extreme temperatures, especially colder temperatures. The problem here is that if there's oxygen, the silicon bonds with that oxygen to form rock. So most likely silicon-based life would be restricted to worlds that don't have any oxygen on them. For example, worlds like Saturn's moon Titan. And for the record, we don't know if there's silicon-based life living on Titan. There probably isn't, but a planet like that, a much colder planet with no oxygen in its atmosphere, could have silicon-based life. This life, since it would not have access to photosynthesis, would probably use chemosynthesis. This is also what life on the dark side of a tidally locked planet would use. This is where the life basically breaks down rocks to extract the nutrients from the soil. The problem is that chemosynthesis isn't nearly as good as photosynthesis in building up complex life, so it's unlikely that these life forms could ever form complex ecosystems. They would just be limited to bacteria. Water is a great solvent because it can dissolve many things in it. However, it's not the only possible solvent. There's also liquid ammonia and hydrocarbons. Again, these two liquids generally exist at much lower temperatures, so they are actually a possibility for being used by silicon-based life. And photosynthesis, which is basically what modern life on Earth is based on, does not need to use green pigment. Here on Earth, life is green plants are green, because they reflect green light and absorb other lights, which they use for energy. However, different forms of plant life on different planets with different environments can use different colors. For example, if you're on a planet orbiting a dim star like a red dwarf star, and especially if that planet is tidally locked. The plant life there will likely be completely black because they need to absorb all the light they can in order to survive. And there is also a possibility that plant life may not be based on photosynthesis at all, but instead on something called retinol, which is essentially an earlier version of photosynthesis. And this kind of life would be purple instead of green or black or red.